Yep. So, okay, we are going to start. Hi, everybody. Really excited to be here. Thanks to HashiCorp for this opportunity to talk about chaos engineering. Thank you very much for attending. Thank you very much. We really appreciate that. So the title of my talk is, our talk, sorry, is building reliability into Kubernetes using chaos experiments with Terraform. So nice to meet you. We are Yuri Niño and Jonathan Hill. We work as site reliability engineers for ADL Digital Labs, a company in Colombia that provides technology and innovation services. We are chaos engineering advocates. We are promoting the adoption of this discipline in our country. They are our contact data if you have questions or if you want to contact us. So before starting, I would like to share this praise from Jen Hammond, who is New Relic Engineering Manager in New Relic. The best time to learn about fire is when you are on fire. And let us start with that. They are topics for today. Jonathan will provide a foundation about site reliability software inspired in the Blue Books from Google. He is going to introduce some basics about Kubernetes. With this context, he is going to explain why Kubernetes is considered as a promise for reliability challenge. At this point, I am going to tell you about two sad stories managing clusters with Kubernetes. Considering that, I am going to present a practice named chaos engineering that is driving the challenge related to reliability. And finally, we are to present you our community that is working in projects related to this practice. So go ahead, Jonathan.
Okay, perfect, Yuri. You will if you're sharing the screen or share my screen. I don't have. Okay,
I am using my screen. So
perfect.
Great.
Yeah. Then we talk about the reliability. Reliability is the more important feature when you define and you deploy your system, because I travel in software about the architecture, about the some of cases and technical leader too. And in this, you needed always define reliability for your software. How to your customers live your software, and how to your software define that, and how to your customers live this reliability. Then with Google, define the reliability like a most important feature and system as a long thing. Take care to point out that reliability often not covers of this area, correct? Then in the next slide, we're talking about the reliability, how to reliability is our responsibility from SREs, the engineers or DevOps engineers in your company, but it's all things that the IT area works from the software and how to your software deploy and how to all operations live in this part on the software, right? Then we're talking about something about this book. It's a very important and very nice book to learn about how to SRE and how to live SRE about Google. But it's could be abstract class DevOps, and implementation is SRE by Google. It's a very good reading if you want to more in deep about SRE. Go ahead, Yuri, please.
Yep.
We're talking about the something of Kubernetes, how to Kubernetes start. Yeah, Kubernetes start always in our environment about the Dockers, how to this discipline, or must be or more. It's a tool that developers use to generate some value, some fast value, generate more speed in our teams. But Kubernetes talks this practice on how to, my desktop on my laptop works fine, but not never can replicate this environment in all defined environments in all systems, right? When you develop the this part, you need to generate these some strategies for the value is the fact of the other environment, right? Kubernetes document about the how to key OS is defined, because all words that key and S is 8 letters, then key OS is defined for that. Let me check about the how to Kubernetes cover these all areas for your company, how to start with all things and the different terminology of that. Ready? Then with Kubernetes, we cover some little glossary that is pod, that is a service, and this a node, and this a master node. In fact, the master node is a virtual machine, could be, that you define how to, this defining Kubernetes like a control plane. And the next one is the node. The node is a child from master node that you use to deploy all your applications. Yeah, when you deploy an application, you generate a lot of strategy. Normally, you use a service, and behind of the service, you use a pod. When you deploy your application, is in the pod. The pod contains all your application behind of some containers and a strategy that the architecture that you use in this deployment, you could be used to generate your deployment, right? And then could be for more fast, but it's a very easy way to generate your application in a less environment and use this less environment for your application live well, with your fat jar could be, or your npm distribution generate, and it's in fact use the most resources from your application and how to these resources work for your application. That you're not disgates some resources from OES or from framework that support my application. That is a little layer from this pod. Then you enjoy your application, enjoy all resources from generate the value from your customers, right? Then
and
I
go
can,
ahead.
yeah, Jerry.
Okay, thank you. Thank you very much, Jonathan, for this introduction about containers, about Kubernetes, and about the foundations of site reliability engineering. Thank you very much. So I am going to continue. So to use Kubernetes, you need a Kubernetes cluster. A Kubernetes cluster is a set, as Jonathan mentioned. A Kubernetes cluster is a set of machines that runs the Kubernetes components and that make the resources, for example, CPO or disk space, available to be allocated and used by your software. That is very important. So those machines are called worker nodes, as Jonathan mentioned, and a single Kubernetes cluster can have thousands of worker nodes. Now imagine, for example, that you have a cluster and you want to run new software on that cluster. Your cluster has 3 working nodes, each containing resource available. Imagine, depending on the resource that the new piece of software needs to, your cluster might be able to run it on the first, on the second, but not the third working node. So let me move to another concept. So now I am going to talk about what happened with some broken promises related to Kubernetes. So reliability and high availability are key features of Kubernetes, but even the most resilient systems can fail. Applications crash, hardware breaks, and nodes can go offline. These failures can have damaging and unpredictable consequences for organizations, especially those that are not prepared. So before to speak about some sad stories using Kubernetes, let me introduce a concept known as black swans. Black swans, or sorry, the term is based on an ancient saying that presumed black swans didn't exist. Black swans are events that comes as a surprise. The theory was postulated by Nicholas Taleb. He is the author of this great book. We recommend this book if you are looking for learning about outage, about unprepared events. The theory was postulated by him and developed in his book to describe the extraordinary events in history, science, finance, and technology that have had a high impact. As Laura Nolan from Slack said in the Usenix conference, the world is chaotic. That is a fact. So black swans take our system down and keep them down for a long time. So the site key is contain a compiled list of links to public failure stories related to Kubernetes. Some failures include network problems, resources, limits such as CPU limits, latency issues, and DNS outage. No cloud providers escapes of the list. AWS, Azure, or GCP have been involved in at least one incident. So here are some sad stories in which Kubernetes has been involved. In the early morning hours on January 8, 2019, Tinder's platform suffered a persistent outage related to Kubernetes. In response to an increasing platform latency, pods and nodes were escaped on the cluster. This resulted in a cache exhaustion of the nodes. We have another story, it's from Buffer, social media tool for authenticating engagement. Tell your brand story and grow your audience with a publisher and topics related with the media, with the social media. At Buffer, they are using Kubernetes since 2016. They have been managing their Kubernetes cluster, they keep ops, and it has about 60 nodes in AWS and run about 1,500 containers. They transition from a microservice architecture with Kubernetes, to a microservice architecture using Kubernetes was full of trial and errors. Even after a few years running Kubernetes, they are still learning about the incidents, about the errors. If you want to check the postmortem site, they have a lot of some incidents related to Kubernetes. So Kubernetes is not perfect, that is a fact. It adds complexity to the systems, complexity that needs to be managed and understood Kubernetes. Kubernetes requires that you follow good practices because Kubernetes offers a lot of benefits, but it is very important to understand how to Kubernetes work. So in potential configurations, applications, and deployment models, for example. A friendly reminder, our applications and workloads have unique requirements and vulnerabilities that require tuning and testing. And the most important, very important, we are prepared for them. So that is the moment to talk about chaos engineering. So chaos engineering is driving reliability. So let me talk about that. Kubernetes was designed with the assumption that components will fail, as Jonathan mentioned, and the context will provide in the past slides. So it has mechanisms for providing redundancy, detecting failures, load balancing traffic, and recovering or replacing components. All of this happens behind the scenes, letting engineers focus on building applications. If one of these components fails, engineers need to know, let me check the time, okay. If one of these components fails, engineers need to know what is the impact on their clusters and applications, how to recover quickly, for example, and how to automate recovery to avoid having to intervene in the future. The only way to answer questions in raw experience. So teams need to deliberately and proactively test Kubernetes by causing failures. So let me remind the definition of chaos engineering provided in this site, principle of chaos. So chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. Chaos engineering is not about randomly shooting down parts in your infrastructure and seeing what happens. Instead, it is more scientific. It is related with the scientific method. So it involves defining an experiment with a clear hypothesis, identifying which systems you expect to be affected by the experiment, and having a means to stop or revert the experiment in the event of unexpected conditions. So let me talk now about the principles. This discipline is practiced following these 4 principles. First, hypothesis about the steady state. It could be difficult because it is not possible to be sure that your software is completely free of bugs. That is a fact. So that is the first part is really difficult. But we are to start with a level of steady state. So in a second part, vary real world events. For example, change the values in a configuration file. So in the third step, run the experiments, verifying hypotheses when servers crash or network connections that are servers, for example. So finally, try to disapprove the hypothesis by looking at difference in steady state between the control group and the experimental group. The idea here is to automate the experiment. So let me talk now about the activities related with these principles, because they are principles, but for example, Gremlin provides a great framework for practicing chaos engineering, in this case with Kubernetes, but in another case. So let me return to this slide. So they are the activities, the proper activities in order to run an experiment. So first one, start with a hypothesis. As I mentioned, that is a principle. A hypothesis is the question that you are trying to answer, and what do you think the result will be. For example, if you experiment to take a Kubernetes worker, no offline. So, my apologies. Yeah, the second step, define your blast radius. The blast radius includes any and all components affected by the test. A smaller blast radius will limit the potential damage done by the test. It is recommended starting with the smallest blast radius possible. In a third step, monitor your infrastructure. This is very important. Consider observability, OpenTelemetry, for example, or that is related to monitor your infrastructure. It is about determining which metrics will help you reach a conclusion about your hypothesis. The aim is taking measurements before you test to establish a baseline. So finally, run the experiment. If this activity, make sure you have a way to stop the experiment and revert any changes introduced before the experimentation began. So this is where chaos engineering comes into play. Performing chaos experiment can reveal previously problems and help us improve cluster resilience before they can become larger problems. So let me use this phrase from Tom Deering, who is a senior software engineer in Workiva, and that is related with that as mentioned. Chaos engineering allows you to consider edge cases and ways that your code may go wrong in ways that you didn't previously consider prior running a chaos experiment. So now I am going to move to some experiments that you can practice if you want to start with chaos engineering in your Kubernetes clusters. So let me talk about this. So although microservices are designed to be loosely coupled, pod failures can directly impact the performance and availability of other services. In a proper scenario, Kubernetes will automatically deploy a replica to replace a failed pod. In one moment, Jonathan is going to show us a demo using this experiment. So let us move in a moment for this. So in this first experiment, you can consider a cluster with all nodes are healthy. That is the steady state. So the hypothesis in this case is if you delete one pod, you should see it marked as failed in a dashboard, for example, in a Kubernetes dashboard. So as you remember, a smaller blast radius will limit the potential damage done by the test. So in this case, our blast radius is one cluster in a region. So finally, in our third step, observability. In this case, we are using Kubernetes dashboard, but you can use Datadog, New Relic, or another tool for monitoring a cluster or a Kubernetes cluster. But it's really important to mention that, for example, logs provide a great way to monitor. So if you don't have these tools, you can use logs, for example. And finally, run the experiment. That is an idea for experimenting with chaos engineering in a Kubernetes cluster. So in a second experiment, we are talking about high availability. Another experiment could be for ensuring high availability in your microservices orchestration. So the hypothesis here is that if a master node in a high availability cluster goes down, the cluster will continue to run as normal. As you know, Kubernetes is high availability offer or provides high availability. So over normal clusters by replicating the cluster's control plane across multiple nodes. Remember, Jonathan explained the concept related to clusters control plane. So with a high availability cluster, the master node is replicated across additional nodes to ensure the cluster remains available. Running chaos experiment on a high availability cluster will help you ensure that this replication process is working as it's intended. So in this case, the blast radius is related with the high availability cluster, and observability, you can use again a Kubernetes dashboard, Datadog, New Relic, or another tool. Grafana with Prometheus, for example, is a great way to have observability over these architectures. So finally, run the experiment. So in a third experiment, it is another cool experiment suggested by Gremlin. It is for analyzing the impact of an outage. So to ensure that, we could run an experiment to shut down a running pod, and monitor Kubernetes to ensure a new replica is created. We will focus on the front-end pod, which handles incoming user requests. A hypothesis in this experiment is when the front-end pod shut down, Kubernetes automatically deploys a replica and routes the traffic for another pod. So that is the moment for the action, and that is the moment for our demo. So Jonathan is going to provide a cool demo for practicing chaos engineering in Kubernetes. Thank you very much.
Thank you, Yuri. Okay, that is a best important about the experiment. We use Terraform like generate all our infrastructure to generate this demo. Use EIC term like generate this part, and
sorry, Jonathan, if you want to share your screen, that is better, I think. Sorry.
Yeah, give me a second. That present screen. Yeah, right. And in this is the presentation in that. Yeah, I guess now show my screen.
Yeah, we can see.
Okay, right. In this part, we're talking about how to use infrastructure as a code using Terraform to generate all infrastructure that we needed to make this infrastructure from the Kubernetes, right? In the second part, this tool is all automated. Could be you put in your CI/CD application, and with that, you could be generate this infrastructure like on Jenkins, Spinnaker, all on your tool that you use in our company. That is a very easy way, right? This is the repos, could be shared more earlier in Slack and slide practice in the Slack part that we have the presentation, right? In one part, we have definition how to deploy and generate infrastructure for the master node or control plane. And the other part, we define how to you generate the nodes that connect with the master node, right? This is a demo that we start in there. In this demo, is very quickly, we define the AWS provider that use this provider to took all features that can be used in AWS. The next one, we define the data. We talk about your VPC and subnet that use. In this part, use SSH key that connect with our cluster, the subject group that you use to connect from to the new application that you generate with this demo. And the last one, this is a script that is a big part of this script. In the part one, we use key OS tool to generate a cluster. In the second part, we generate the kubeconfig that is the most important in your cluster. And the third part, we generate the kubectl tool that communicate the kubeconfig with your cluster, and this is a tool that communicate with the all API the cluster generate, right? That is the last one part, is when the IP get from my screen from the generate infrastructure. And in the next slide, we generate the I don't know if past master. In this part, we generate the this is not the master. This is the part of node. Sorry. In this part is the same like a master, but changes the master, the script that communicate the master node with the node mode. Then you need a token to communicate the master with the node provide in this part, right? Then use SSH key, the security group that you need, and the machine that you generate that is infrastructure in this part. Let me move fast and then, okay, we're talking about the AME that you use, and the script is more little than the master. And the next one, node. This is the part on how to show this infrastructure generated by Terraform with all my connection. Then in the top of presentation is the AWS view that you check the master and node generated. That is a worker node. And the part of behalf is the master and how to the node was registered in this master, right? This is the Kubernetes dashboard that installed in top from the master node. In this part, we deploy one pod that generate from the application sent from the master node to generate this deployment, right? The deployment generate a service and pod behind the service. With this tool, you can provide the service from your customers. Is the first part they're looking for, and just seeing how to Kubernetes deploy your application in this master in this cluster, right? Behind the the next step that execute is the a killing pod that it's a script called Thanos Kubernetes. In this script, just kill the pods from the node, and this generate how to the pods look in the dashboard and how to the deployment and how to Kubernetes apply the all magic that you define in your deployment and how to they restore automatically the new pod and how to generate the same service and how to the Kubernetes generate the same value for your customers and not end the service because Kubernetes generate new pod from your customer, right? Then in this part, it's very nice because Kubernetes takes the control about your application and how to convert all application in reliability mode. It's a very good form to generate, but it's not magic simply. Just you need to learn about a lot of Kubernetes and how to your deployment works and how to pod works and how to service works and how to this deployment works together with the deployment and your pods and how to Kubernetes generate this reliability for my application, right?
Okay. So I'm really sorry. That's yeah. Kubernetes is a very difficult topic, and I know that there's a lot about it to say. But yeah, it's we have a tight schedule, unfortunately. So
yeah.
Yeah, I really want to thank you for your talk. It was super interesting. Do you have any of the resources that you can share with the people on the YouTube chat?
Great. So we are going to share the site in YouTube where the videos are available. Thank you.
Excellent.
Thank you very much for your time.
No problem. Thank you so much for joining us today, and have a lovely rest of your day. Stick around.
Okay.